Cloud CI/CD pipeline compromises represent a critical threat, allowing attackers to inject malicious code directly into software development and deployment processes. Attackers target CI/CD pipelines due to their privileged access to sensitive systems and the implicit trust placed in them by development teams. The automation inherent in CI/CD means a single compromised component can rapidly affect downstream systems and ultimately customers. High-profile breaches like SolarWinds, CodeCop, and CircleCI demonstrate how attackers are increasingly targeting these systems to poison entire software supply chains. Several risks and vulnerabilities make CI/CD pipelines attractive targets for malicious actors. Insecure code practices allow vulnerable code to slip through, exposing applications to exploitation. Insufficient access controls, such as broad permissions, can allow unauthorized actors to modify code or access sensitive resources. Security misconfigurations in intricate CI/CD environments offer many opportunities for exploitation, including open ports and weak permissions. Exposed secrets and credentials, like API keys and passwords, are often hard-coded or committed to Git repositories, creating significant risks. Dependency chain abuse involves malicious actors injecting vulnerabilities into external dependencies, which then propagate through the pipeline. Pipeline tampering and code injection allow attackers to alter-build scripts or inject malicious steps, leading to unauthorized code execution. Ungoverned usage of third-party services can introduce vulnerabilities and data leaks into the pipeline. Insufficient flow control mechanisms can lead to unauthorized changes, bypassing critical tests, or deploying unverified code. Understanding the attack methods and techniques is crucial for effective defense against CI/CD pipeline compromises. Attackers begin with reconnaissance, identifying how an organization operates, followed by initial access through credential theft or pull request injection. Once inside, they move laterally to identify the CI pipeline management service, then target and poison the pipeline by injecting malicious code. This leads to clients uploading poisoned images, establishing malicious beacons to command and control infrastructure, and ultimately, the attacker gaining keyboard access. To mitigate these risks, organizations must implement robust best practices for securing their CI/CD pipelines. Adopting a DevSecOps model integrates security into every stage of the DevOps lifecycle, while strong access controls like RBAC and MFA restrict unauthorized access. Secure coding practices and automated security testing, including SASD, DSD, and SCA, are essential for identifying vulnerabilities early. Effective dependency management involves pinning dependencies, regular updates, and scanning for vulnerabilities in third-party code. Securely managing secrets and credentials, preventing hard coding, and scanning infrastructure as code for flaws are critical steps. Continuous monitoring and logging provide end-to-end visibility, enabling rapid response to security incidents. Developing and regularly testing an incident response plan, along with continuous updates and patching, strengthens overall security posture. Network segmentation limits the blast radius of a compromise, and the principle of least privilege minimizes unauthorized access. Finally, implementing drift detection helps quickly identify unauthorized changes or misconfigurations in deployed infrastructure. By understanding attack vectors and implementing these best practices, organizations can significantly reduce the risk of CI/CD pipeline compromises and protect their software supply chains.